Alright, day 12. This is a test covering all the concepts in this unit. We're working on circles, and we've been dealing with the angles and the arcs that go with them. So let's just go through this and see what we see. It's a good review. So first, vocabulary. Secant. Well, actually I need to start with these things down here. So number one, segment ML. Segment ML is right here. That is a chord. So I'm going to put G. Alright, number two, circles S and F. When we say circle S, we're talking about the circle with center S. And so here's circle S, and here's circle F. And they are congruent circles. So I'm going to put C. I know they're congruent because they both have a radius of 4. Number 3, point P. That is the center of a circle. Number 4, segment HJ. HJ is a tangent. It's not a common, well, you know what, it is a common tangent because it's touching both of these circles. So this is a common internal tangent. So I'm going to put I. Let's see, segment GE. That is right here, so that's a diameter. So that's F. Segment OJ. Let's see, OJ goes like this. You know what? It looks like they mean for that to be a secant. But whoever wrote this test, this really should be a line symbol over the top of it. So I'm going to have to deal with that. Number 7, segment ST. Let's see, ST is a radius. So that's H. And segment BC. Alright, that is a common tangent, a common external tangent. So that's going to be J. Alright, for number 9, we need to find EH. Alright, so we're looking for this right here. A radius is always going to be perpendicular to the tangent. So I know this is a 90-degree angle. So what else? WE is 6. So I know that this is 6. WH is 10, so this is 10. So Pythagorean Theorem. So we'll just do x squared plus 6 squared is equal to 10 squared. So that means x squared is going to equal 10 squared minus 6 squared. And then we will take the square root of both sides. Put that in the old calculator. 8. Okay, so EH is equal to 8. Alright, looking at number 10, AB, is AB a tangent? Justify your answer. Well, there's sort of a little proof to this, but the bottom line is we need to check to see if the Pythagorean Theorem works. If the Pythagorean Theorem works, that means that this is a right triangle, and specifically this is a 90-degree angle. And only a tangent will form a 90-degree angle at the radius. So that would prove it. So off to the side, let's just check and see. Does 3 squared plus 6 squared equal 7 squared? Okay, so of course that would be 9 plus 36. Does that equal 49? Well, actually that's 45. Alright, 45 does not equal 49. So, okay, the Pythagorean theorem did not work. So, the answer to the question, is it a tangent, is no. Now, here's our justification. It's going to take us 4 lines to do this. I'm going to number them just to make it extra clear. Alright, the first line is going to be since, you know what, I'm going to, since 3 squared plus 6 squared does not equal 7 squared, triangle ABC is not a right triangle. So, segment BC is not perpendicular to segment AB. So, segment AB is not a tangent. Alright, that is how you justify that. It takes about 4 lines. Alright, look at number 11. What is the radius of the circle? So we're solving for r. We're just going to use the Pythagorean theorem, but just be careful. The hypotenuse is r plus 9. So we will do a squared plus b squared equals c squared, but that'll look like this. R squared plus 15 squared is equal to r plus 9 squared. Make sure you do not try to square the two pieces. Don't just put r squared plus 81. Instead, you have to do this. R plus 9 squared means r plus 9 times r plus 9. Now, when you look at it this way, I hope that you will remember we need to distribute this r twice. So, we need to multiply r times r and r times 9. So far that's going to give us r times r is r squared, and then r times 9 is 9r. But then we also need to distribute the 9. 9 times r is 9r, and then 9 times 9 is 81. So we get all of this. So that's going to give me r squared plus 225. Let me bring that down. 9 plus 9, so that's going to be 18r plus 81. Now I can subtract r squared from both sides, and those are going to just cancel each other out. So let's see what we have now. So that's 225 is equal to 18r plus 81. Now I could subtract 81 from both sides. So that is 144 is equal to 18r. Time to divide by 18, and I get r is 8. So that is the radius of the circle. So number 12, we're going to find the value of x. When you have a common tangent like this, they are always going to be equal to each other. So we can just set them equal to each other like this. 5x minus 4 is going to equal 2x plus 2. So subtract 2x from both sides, so that'll be 3x minus 4 is equal to 2. Go ahead and add 4 to both sides, bring it over here, so that'll be 3x is equal to 6. Go ahead and divide by 3. And I get x equals 2. Alright, that was the value of x. Alright, number 13. Let's see what's going on here. Alright, we're supposed to find the measure of angle EFD. Well, EFD is this angle right here. So this is our target. Well, that was easy because this is just, these are vertical angles. and vertical angles are always equal. So that will simply be 50. Number 14, we're supposed to find the measure of angle BFC. So let's see, BFC is right here, so this is our target. And what we can do is, let's look at the semicircle. Alright, here's a semicircle. Alright, because this is a diameter, we have a semicircle right here. So I know that's 180 degrees. But if you look carefully, I have 50 here, I have 75 here. So I have everything except for this missing piece. So if I can just subtract these from 180, so basically if I do 180 minus 50 minus 75, that should give me the missing piece. And that missing piece is 55 degrees. So I'm going to go ahead and put that in here. So this is 55 degrees. So it's BFC, yeah, so it's 55 degrees. Alright, number 15, find the measure of arc EA. Okay, that's this out here. Well, look, we have everything except for this arc. But you know what? It will be a little quicker if we again look at the semicircle. If we use this diameter and we look at this semicircle, it's going to be really easy. These two pieces have to add up to 180. So if this was 130, 30 plus 50 is 80, so that would make 180. So this must be 130 degrees. Okay, last one from this part. The measure of arc DEC. Alright, DEC, okay, that's going to be the long way around from here all the way around to there. So the quickest thing to do would be to recognize that this red part of the circle is everything except for the green arc 75. So the quickest thing to do is to subtract from 360. So if I do 360 minus that 75, that should be everything else the rest of the circle. So that's going to be 285 degrees. Alright, now look at number 17. Notice that we're being asked not only to find the measure of x, but also to find the measure of angle DEC. So we're going to have to wind up finding x, but then plugging it back into the expression to find angle DEC. First of all, let's see, DEC. DEC is this angle right here. And on the other hand, DFC is this angle right here. Okay, but we know that these two angles are always congruent, so it would make sense for us to set them equal to each other. So 3x minus 24 should equal 2x plus 8. We can subtract 2x from both sides like this, so that's going to give us x minus 24 is equal to 8. Whoops, I mean 18, I mean 8. And if we add 24 to both sides, then that's going to give us 32. Okay, so x is 32. But if I want to find the measure of DEC, well, DEC is 2x plus 8. But now we know that x is 32, so that makes this 2 times 32 plus 8. So that is 72. Alright, so that's number 17. Let's see, let's look at 18. Find the measure of arc BC. Okay, let's just play with this a little bit first. If this is 31 degrees, I know that this will be 31 degrees. When you have this bow like this, these angles that are on the same side of the bow are always going to be the same. So B and C will be the same, and A and D will be the same. So I know that angle A is going to be 73. Now, to find arc BC, that's just going to be double this angle. So just double 73, and that gives me the arc. So that is 146 degrees. Measure angle A. Oh, we already have it. So that's going to be 73 degrees. No problem. Alright, let's move on. Now, as soon as you see a quadrilateral that's inscribed inside of a circle, the property that should be popping into your mind is the opposite angles are going to be supplementary. So this and this should be supplementary. So if I subtract from 180, I should get angle Z. So that is going to be 82. So that's angle Z right there is 82 degrees. Angle W, same thing. Just subtract from 180. So these two are the angles that should be supplementary. So 180 minus 92. So that will be 88 degrees. Okay, take a look at number 22. Find the measure of x. Well, this is just going to be a straightforward use of the formula that says the arc is equal to, the angle should be equal to the big arc minus the small arc divided by 2. Alright, that's the formula for this situation. So just put that in your calculator. That turns out to be 49. Okay, good enough. Let's look at 23. Find the measure of arc ACB. Well, arc ACB is this arc the long way around like this. And that arc should be double this angle. So that should simply be 240 degrees. Pretty simple. Moving on. Alright, number 24. Okay, the formula that applies here is like this. Angle equals arc plus arc divided by 2. But here the angle is the 70. So make sure you put your 70 out in front. And then arc plus arc, so that'll be like x plus 66 divided by 2. So in order to solve this, we will just multiply both sides by 2. So that's going to give us 140 is equal to x plus 66, because these cancel out. We subtract the 66 from both sides. And we find that x is 74 degrees. Okay, number 25. Alright, whenever the angle is outside of the circle, the formula that we're using is angle equals big arc minus small arc divided by 2. So in this case, the two arcs that we need are this arc right here, that's 125, and this arc right here that right now is not known. I have to have both of these arcs. You know, the angle is already a variable, so I can't have any more variables. So the first step is to find out what this second smaller arc is. Luckily, we have all of the arcs given to us in the circle except for this one, so I should be able to subtract all of these from 360, like by doing 360 minus 105 minus 125 minus 75. And that's going to give me the missing arc. Alright, that turns out to be 55. So I'm going to go ahead and put that in. So this arc is 55. So after that I can just use the formula. So x is going to equal the big arc, which is 125, minus the small arc divided by 2. Alright, just put that in your calculator. So that comes out to be 35 degrees. Okay. We are cutting through this like a hot knife through butter. Okay, so we're supposed to find arc GH. So arc GH here is our target. Wow, is this really so simple? This is just going to be double the angle. So that should be 54 degrees. Wow, this was really, really simple. Okay, maybe this one will be more challenging. Or not. Find the measure of angle BAC. Yep, another super easy one. This inscribed angle should be half of the arc, my friends. So it's just gonna be 80 degrees. Kabam! What now? Yeah, it's my daughter over there is playing Minecraft, so if you hear some zombies growling in the background, or hissing spiders, or yeah, a teenager, that would be my daughter. Oh yeah, chickens. My wife is playing too. We need to find x. Okay, when we're inside the circle like this, we're using the formula that goes angle equals arc plus arc divided by 2. X is the angle, so this will be pretty super easy as long as you remember the formula. So x should equal 131 plus 33 divided by 2. Alrighty then. So that is 82. Okay, let's look at number 29. Solve for x, y, and z. Okay, I'm just looking around here. Couple of things. I see the 60. So let's just go ahead and get that out of the way. 60 is the arc that goes with angle z here. Alright, and so the angle should be half the arc, so at angle z will be 30. Okay, fine and dandy. What's next? Well, semicircle, hey. If we look at the semicircle situation, see we have a diameter happening like this. So the semicircle is going like this. So, ergo, if this part over here is 60, then this part over here, if we subtract from the 180, that's going to leave 120. Okay, so arc BC is 120, which means that x is going to be half of that. So half of 120 is 60, of course. So kabam. So x is 60. What now? What now? Yeah, well, looking at the y, the y is across from this other semicircle. So, you know, there's more than one semicircle. If you look at the semicircle that goes this way, okay, this is also a semicircle. So since this is 180 degrees, y is across from the 180 degrees, so that's going to be 90. So angle y is going to be 90 degrees. Okay, we're almost to the end of this, and so far this has been ridiculously easy. Number 30 is a little bit more challenging. We have covered this in previous videos, and I think if you look at video number 11, you'll see this almost a problem just like it. Basically, there are two problems in one. So just focus on this part. Forget about the y for a second. Just look at the x. These are these formulas that we're using over and over again. But as we go to find the x, I think you'll notice the lines that are intersecting inside the circle. You'll see an angle at the point of intersection. So this is the formula that we're going to use first. Angle equals arc plus arc divided by 2. So watch out for this situation. So looking back, so what you just have to do is focus your eyes on this part. Ignore everything else. You know, look at these intersecting lines. Okay, so what we have here is, let me highlight this for you. We have this angle, and we have this arc, and we have this arc. So, using this formula, the angle equals arc plus arc divided by 2. So we're going to do angle equals arc plus arc divided by 2. And that will help us find x. So if we follow through and do that, then the angle is 94. So just make sure you start with the 94. So it'll be 94 is equal to x plus 142 divided by 2. And then we need to multiply by 2 on both sides, like so. So these are gone. So that's going to be 188 is equal to x plus 142. And of course we will subtract 142 from both sides. Whoops, 142. So that tells us that x is 46. Alright, so that's that. We have x now. So now let's refocus our eyesight. Now that we know what x is, just to make a point, I'm going to go ahead and write it in right there. So now it's time to turn our attention to the y. Now if you focus on the y, we're looking at this situation that's going like this. Okay, so if you ignore everything except for the red angle and again the arcs, then what we have is we have an angle, and then that's outside of the circle. So that puts us in this situation, the fourth formula. And the formula for that is the angle is always equal to the big arc minus the small arc divided by 2. So that's what we're going to use to find y. So this angle is going to equal the big arc minus the small arc divided by 2. That's how you do it. So y is the angle. So I can go ahead and just go y is equal to big arc minus small arc. Whoa, why did I put 48? Why didn't you guys tell me? It's 46. You just silently sat there and let me put 48. I feel all stupid. Okay, that's 46. So that's going to be 46. That's what I mean. So put that in your calculator, and that will give you the answer. So y turns out to be 48. You can sing if you want, if you don't mind being in the background of the video. So, yeah, sometimes I get in trouble for copyright infringement if I have Maroon 5 or something playing in the background. Something tells me I'll be okay if you're singing in the background. Let's see, in the figure below, Q is the center. Which angle is a central angle? Angle 1? Nope, that's inscribed. Angle 2, inscribed. Oh, ding, 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 angle 3, that's a central angle. Oh, because it's at the center. Okay. Man. You guys that actually took this test, you know, as opposed to random people from the internet that might watch this someday, you better have got an A or at least a B, because this is about the easiest test I've ever seen in my life. You know, I mean, problem number 30 was a little tricky, but, I mean, goodness. Such, right over the plate, straight down the middle. You're welcome, is what I'm saying. Last one, figure below. The circle has a diameter of 5. Diameter of 5. Not radius, diameter. So that means from here to here is going to be 5. What is the length of chord XY? Okay, so that's this over here. Alright, just a straightforward Pythagorean theorem, so let's do it. X squared plus 3 squared is equal to 5 squared. So that's going to be x squared. You know, and I already can see it's going to be 4, because it's going to be a 3, 4. So the 3, 4, 5 triangle is the most famous right triangle in the world, so it's obviously a 3, 4, 5. But just to follow through, this is going to be x squared equals 5 squared minus 3 squared. Then you would take the square root of both sides, like so. Whoops, not like so. Got a little carried away there. Like so. And sure enough, as predicted, x is going to equal 4. So the answer is B. Alright, and that is how you do that, ladies and gentlemen. Hope you enjoyed this presentation of the easiest circle quiz ever. If this was helpful to you in any way, please hit me up with that thumbs up. Like me. Makes me feel loved and appreciated. And I will see you on the next video. This is probably the last video for this unit. So I will see you in Unit 4, Part 2. Yeah, bye now.